we are talking about degree of freedom analysis. So what is a degree of freedom analysis? It is basically a step you do before you try to solve your question. So why we need this step? So sometimes if you don't do degree of freedom analysis, you have the information, you get your question and you start calculating to solve the question. And sometimes after doing a lot of calculation, you derive your equations, you substitute all the values, and suddenly you find out that you don't have enough information to solve the question. Okay, so to avoid that, we must first do degree of freedom analysis. So that is why we do degree of freedom analysis. So how do we perform degree of freedom analysis? So that's why our third step is important. We need to have drawn and labeled the flowchart. Ensure all the information given has been placed in the flowchart. So as we did for our first example just now, whatever information we had, we drew and we labeled on the flowchart, on our figure. Then we need to count the total number of unknowns variables on the flowchart. And we also need to find the number of independent variables relating to this unknowns. So this is, please pay attention to this one and this one. Okay, so that is why I put a lot of emphasis and drawing and labeling completely, because whatever you have drawn and you have labeled in your flowchart, you will use that information to count for your number of unknowns. Number of unknowns here meaning that whatever value you do not know, whatever value you want to find. Okay, and then number of independent variables is actually whatever information is given to you and whatever relationship you can make between one variable to another variable in order for you to use them to solve for the unknown variables. Okay, so for degree of freedom analysis, this is the formula. ND is degree of freedom, and unknown is the number of unknown, and N independent is the number of independent equation you can make. So if you have ND equal to 0, there are equal number of unknown. For example, let's say I put here I have 4 unknowns. In order for me to get ND equal to 0, I have to have 4 and independent. But 4 minus 4 is 0. So that's why we say that there are equal number of unknown and independent equation, and the problem can be solved. Okay, so you have to make sure that every time you want to do mass balance question, step 1, step 2, step 3, this is step 4. So whenever you do your step 4, you must make sure that your ND is equal to 0. Only then you can solve your material balance question. If you have ND greater than 1, meaning that your number of unknown is more than the number of independent equation. For example, you have 5 unknowns. Okay, so for example, you have 5 unknowns, but you only have, let's say, 3 or 4 independent equation. So your ND can be equal to 1 or can be equal to 2, because 5 minus 3 is 2 or 5 minus 4 is 1. So if ND is greater than 0, 1, 2, 3, 4, no matter what, they are greater number of unknown than independent equation, and the problem cannot be solved. Okay, so this is a very, very important rule. So before you say that the problem cannot be solved, please make sure you check if you miss any correlation of equations to solve the problem. If let's say you have checked and you are sure that you have labeled everything, you have drawn the flowchart correctly, everything is correct, but you still find out that ND is greater than 0, then to solve this problem, you are supposed to be given more information. So that is why, if let's say you have this situation, so you are sure that you cannot find any more information, so there is no point for you to solve, to continue further. Stop at step 4. You don't have to go to step 5, step 6, step 7. Just stop at step 4 and say that this problem is unsolvable. So you are actually saving a lot of time. You're not wasting your time deriving the equation, writing the equation, trying to solve the equation, just to find out that the problem is unsolvable. So this is a very, very good indication of why you should do degree of freedom analysis. So the next criteria is that if ND is great, so this one should be ND this one should be less than 0, sorry. If ND is less than 0, meaning that if ND is less than 0, meaning that you have more information than your unknowns. So meaning that you have the value of ND is negative. So for example, if you have 3 unknowns, all of a sudden you can create 4 independent equations. So this is also not acceptable, meaning that there are greater number of independent equations than the unknowns. The problem is over specified. Okay, so first of all, you must check if you miss some unknowns. So again, go back to your step 3, draw and label properly, or you have redundant or inconsistent equations, meaning that this question is also unsolvable. Because if you have more number of independent equations than your unknown, meaning that you can have 2 answers for the same unknown, okay, which is not correct. Okay, so the only way for you to solve is that this condition, ND must always equal to 0. Only after you know that ND is equal to 0, then only you proceed to step 5, 6 and 7. Okay, so this is also a very, very important thing for you to understand. Now, finding the number of unknown is easy. Okay, finding a number of unknown is that you just find whatever the unknowns variable you have. When you label, you will see that, okay, I don't know the value of P, I don't know the value of WH2O, WNaOH, or all these things. That one is easy. But the difficult part is that how to find the value of number of independent equations. So these are the steps. Okay, the first thing you do is that after you have labeled everything, after you have found the number of unknown, first of all, find the total number of species involved in the system. You can write as many independent material balance as there are species involved in the system. Okay, so if your system have, for example, just now we have NaOH and H2O, so you can only have 2 independent equations there. Okay, because we only have 2 species involved in our system. The second one is that explicit relations specified in the system. Example, flow rate of stream 2 is twice the flow rate of stream 1, or just now in our question we say that the ratio of water to the product is 0.9. So that is our explicit relation. And then you can find implicit relation. So particularly the sum of mass or mole fraction being to 1. So that's why you need to know how to calculate your mole and mass fraction, and the total value must always equal to 1. You can now have more than 1. Okay, and then specified value of variable that are given in the problem statement, and also the basis that you have chosen. That's why again you have to choose a very, very good basis value. Okay, so those are the steps you need to know on how to solve degree of freedom. So if you are successful in getting your degree of freedom, getting to ND is equal to 0, then you won't have any issue to solve your mass balance problems. Okay, so before I go to the examples, Do I need to explain or do I need to repeat anything until now? Any questions? Anybody? So far so good. Okay, anybody else? It's okay, you can ask question. You sure you understand whatever I'm talking until now? Everybody understand? Or everybody is too shy or too lazy to ask any question? Anybody? No one. Okay, very good if you understand. I hope that everybody understand. Okay, if you don't understand, please let me know, because if you are unable to do this step, can we try some question? Okay, we can try after this. So just I want to reiterate myself. If you have any issues, if you are unable to solve this question, then you will have very difficult time in actually solving. Okay, so this is the first step. Okay, so if no question, then we can just try example. Okay, so I want you to try this. So just now we already label. Okay, while I'm labeling again, so just let me just write. Okay, so I'm not going to label it, I'm not going to draw it again, but I'm just going to, I want you to give me the value of this one. I say ND is equal to NU minus NE, right? So I need you to tell me what is the value of NU and how many NE can you find. NE can be divided into the number of species, the number of explicit deletion, and also implicit reaction. So how many values are there? First of all, start with the number of unknowns. How many number of unknowns can you have?
它昨天教的是属于怎么分析一下一个非化学反应的不同系统，然后今天就是在讲说他可能之后就会讲怎么去，就是说根据这些系统是不同类别的，就昨天分出来然后进行计算。但他现在这里好像在做，他现在这里好像在。
Okay, anybody can help me to find what is number of unknowns? Two unknowns question mark. What does it mean by question mark? Okay, two unknown. The unknowns are the composition and the product flow rate. Okay, anybody else? Anybody else want to try? So I've just redrawn this our flow chart, right? So from here, what value you don't know? Just looking at this flow chart. M3, P and F3. What is F3? I don't see any F3 here. P, okay. So let us just try to write down whatever value we don't know. So everybody is saying that we don't know the value of P. Okay, that is one unknown. What is another one is F2. Okay, that is two unknown. What else value you don't know? W. W for what? Composition of product. Mass. WP. Just by looking at this flowchart, what value am I missing? Time. How can you find time? W for P. So what W do you have for P? W. Ratio for NaOH. Okay. Still not there yet. Anybody else would like to try? So this is correct. This is also correct. So now we have two unknowns. Anybody else would like to try? What does it mean by composition? Okay, if I tell you the flow rate of product, okay, the flow rate of product is the P value. Okay, this is the flow rate of the product. So what is the composition of the product? Which symbol or letters here represent the composition of the product? It should be WH2O and WNaOH, because the composition here is referring to the mass fraction. Okay, it's referring to the mass fraction. So if I'm looking for mass fraction, then I have mass fraction for water and mass fraction for NaOH, because this is a mixing system. When you are mixing a pure component of NaOH and a pure component of H2O, you will end up with a aqueous solution, which is a combination of NaOH and water. So when you have a mixture of a solution of NaOH and water, so there must be a mass fraction for water and mass fraction for NaOH. So that is the other two unknowns that you don't know: mass fraction for water and also mass fraction for NaOH. So in total, I have 4 unknowns. Okay, so that is the first step, trying to find the unknowns. That is why it is important for you to properly label your process flowchart. Now I want to find, so I know that my NU is equal to 4. Now the next step is to find my NE, okay, my independent equation and relationship. So for N, first of all, we start with our number of component or number of species that we have. So we have here, this is number 1, we have NaOH, and this is number 2, we have H2O. So I have 2 independent equation that is relating with NaOH and H2O. What other information do I have? I have an explicit relationship. This is the explicit relationship, right? I've labeled it here. I know that F2 over P is equal to 0.9. So this is also an independent equation. So I have another one, independent equation. What else do I have? I have an implicit relationship between mass fraction of water with the mass fraction of NaOH, meaning that whatever mass fraction we have, we always know that mass fraction of H2O plus mass fraction of NaOH must always equal to 1. So this is another implicit relationship or equation I have. So in total, I have 4 number of independent equation. So now I have Ne is equal to 4. So 4 minus 4, I get my degree of freedom is 0. So I can say that my Nd is equal to 0, meaning that I have enough information, enough independent equation to solve for my all the unknowns. So this problem is actually solvable. So since this problem is solvable, I know that based on my degree of freedom analysis, so only then can I move to step number 5, step number 6, and step number 7. Okay, anyone have any confusion on how to get number of NE and number of unknowns? You can ask me now. Can you explain again why WH2O? Okay, so WH2O, sorry. WH2O WH2O is your mass fraction, okay, and WNaOH is your mass fraction. So mass fraction, how do you get mass fraction? So this is Dr. Hani has already taught you. So I'm gonna repeat this once. Okay, so ignore all these things. Okay, so for example now, let's say I have 10 NaOH, 10 kilo, sorry. So I'm just going to show you one time how to get mass fraction, okay? So hopefully you understand. 10 kg of NaOH and 10 kg of H2O. So in order for me to find the mass fraction of H2O, is that mass of H2O, which is 10 divided by mass of total, which is 10 plus 10. So I get 0.5. Okay, so that is my mass fraction, 0.5. So if I want to find the mass fraction of NaOH, I do the same thing. I know that my mass of NaOH is 10 and I know my total mass is 20. So I can get again 0.5. So 0.5 plus 0.5, I will get 1. So your mass fraction or mole fraction must always be equal to 1. You cannot have more than one fraction. You cannot have mass fraction more than 1. Okay? How to find Ne? What to find in Ne? I don't understand your question. What do you mean what to find in Ne? Ne is your independent equation. Okay, independent equation meaning that how the number of equation you can write so that you can solve for your solve. So Ne is basically, so Ne is your independent equation. Okay, so independent equation meaning that what are the number of equation you can write. So just now I said that our independent equation is 4. So what are the 4 independent equation? The first equation is this equation. F2 is equal to 0.9 P. This is my first equation. Second equation is that mass fraction of H2O plus mass fraction of NaOH is equal to 1. This is my second equation. My third equation is NaOH and H2O related equation. So I know that I can have these 4 equations. So by using these 4 equations, I can find all my unknowns, which is F2, which is P, which is W, H2O, and W, NaOH. Okay, so in degree of freedom analysis, we just need to find first whether we have enough number of equations or not. What are those equations? This one we'll look at in our next week classes. Okay, so next week's classes we'll develop the equation and we'll solve the equation. Okay, so for now you need to find what are the number of equations you can write. Okay, so if I just say that another equation I can write for NaOH is that, okay, so I know here the mass fraction of NaOH here is 1. The mass for H2O here is 1. Okay, so I can write here mass of NaOH, which is 1000 times 1 is equal to P times mass fraction of NaOH. Okay, so this is my third equation. I can do the same thing for H2O. H2O, I don't know the fit, so I know F2 is equal to P times mass fraction of H2O. So this is my equation number 4. So now, by using all this equation, I can actually solve and find the value of F2, P, and WNaOH and WH2O. Okay, so those are your independent equation. Independent meaning that they are not related to each other. Okay, so that's why we have independent and dependent equation. So if I were to say that what are the dependent equation? Dependent equation here meaning that you will create the same thing. So for example, let's say I just give you an algebraic equation. Okay, so x plus y is equal to 2. This is my first equation. My second equation I put here is 2x plus 2y is equal to 4. This is my second equation. But based on this, I know that equation 2 is actually dependent on equation 1. Why? Because in order for me to get equation 2, I just times everything with 2. So meaning that equation 2 here, 2x plus 2y is not independent. It is a dependent which is dependent on equation number 1. So that is why this one cannot be considered in our degree of freedom calculation. We cannot have dependent equation. We can only have independent equation. So let's say if I put here, this is my equation 1, and I say that 4x plus 3y is equal to 11. So this is another equation, and I know that this equation is not an dependent equation. It is independent of equation number 1. So I can actually use equation 1 and equation 2 to find the value of x and y. Okay. So if you still have confusion, so I've uploaded 2 videos on degree of freedom analysis. So you can watch the videos, and you can also try to do degree of freedom analysis on this. First of all, you draw, you label everything, you put all the information that you are given here, and you find your unknowns and you find your number of independent equation. Okay. So next week we'll try to look at some examples, and we'll try to solve some examples for that you can actually understand better. Okay, any more questions before we end our class for today? I think we have about 5 more minutes to go.